Hello guys, so in today's video we're going to work through a summary of the content that we worked on in the previous week. So if you watched the previous videos, you'll know that we were working on how to find the equation of a straight line. And in the first video, part 1, we used this formula here, and then this formula, and then in part 2 we used this formula, and in both situations we were given 2 points on a line. So one situation we didn't consider was when you're given the gradient m and 1 point a. So in today's video, what we're going to do is we're going to work through 3 exercises. So the approach will be, for each exercise we're going to compare the 2 methods. So for instance, to get the equation of a straight line, given that m equals 5 and a point A with coordinates 3 and 2, we're going to find the equation of a straight line firstly using formula 1 and then using formula 2, and then compare the solutions. So let's start. So for number one, so we're going to use the equation y equals mx plus c, the formula yx equals mx plus c. So firstly, what we're going to do is we're going to substitute the gradient into this formula. So number 1, going to sub m equals 5 into the formula y equals mx plus c. Okay, and that gives us y equals 5x plus c. Next, what you want to do is number 2, take this point A, substitute it into this formula to find the value of C. So to do that, all we'll do is we'll sub A 2 into the equation y equals 5x plus c in order for us to get the value of c. So that said, we're going to substitute for y, we're going to substitute 2 equals 5. Okay, sorry about that, let me just write that below, let me just scratch that out. So going to have 2 equals 5, and then for x we'll substitute 3 plus c, and that gives us 2 equals 15 plus c, and then just take 15 to the other side and we have 2 minus 15 equals c. Therefore we have c equals minus 13. Now once we have the value of c, all we have to do is substitute it back into this equation. So step 3. So step 3, just substitute c equals minus 13 into y equals 5x minus c plus c, sorry about the c, yeah. Then we have y equals 5x minus 13, and that is our equation of a straight line. Okay. Now we're going to calculate the equation of a straight line using the second formula, y minus y1 equals m times x minus x1. So y minus y1 equals m times x minus x1. So firstly, what we're gonna do is substitute the value of m. So number one, we'll sub m equals 5 into our formula y minus y1 equals m times x minus x1. And that gives us y minus y1. Then we substitute 5 where we have m, so 5 times x minus x1. Sorry. Then second step, we're going to use now the value of a. So we're just going to substitute this point into our formula. So we sub a 2 into this formula. So we have y minus y1 equals 5 x minus x1, and then we substitute a. We have, so where you substitute this is where we have y1 and x1. So we have y minus, so for y1 we substitute 2. We have 2 equals 5x minus, and then for x1 we substitute 3. So we have 3. That gives us y minus 2 equals 5x minus 15. Then we have y, take 2 to the other side, we have 5x minus 15 plus 2. Okay, and that gives us y equals 5x minus 13. Then we see that both these methods give us the same answer. So before I go to the next example, what I want you to see, or the whole point of this exercise, is for you to see that you can use more than one approach to get to the answer. And another thing, it will all depend on your preference of which method works best for you. So in our next example, we're given that a equals 0 and 2, or a has the point a has the coordinates 0 and 2, and b is minus 2 minus 5. So before we even get to the formulas, one thing you have to notice here first is that this point where x is 0 and y is 2, this is the y-intercept, and this is an important factor in this example. So okay. So for example 2, we're also going to compare the two formulas. So we have y equals mx plus c, okay, and y minus y1 equals m times x minus x1. Okay, so for this first formula, what we're going to use is a, the y-intercept. So to find c, we're going to use the point A. So step 1, we're going to sub A 0, 2 into y equals mx plus c. And that gives us, for y, we have 2 equals m. And then for x, we substitute 0 plus c. And then we know that any value times 0 is 0 plus c, which basically gives us c equals 2. Okay. Next, we need to find the gradient. So in order for us to find the gradient, we're not going to use this value. Do not use this value. You're just going to complicate your life if you use the point A. Because the moment you use the point A, there's no m for you to solve. So let me just firstly sub c equals 2 back into our equation. So we have 2 into y equals mx plus c, and that gives us y equals mx plus 2. Okay. Step 3, we need to find the gradient. Do not, like for this situation, when you're using this formula, do not use the y-intercept to find the gradient. Do not use the y-intercept to find the gradient. I'll say that one more time. Do not use the y-intercept to try and find the gradient, because it's just going to cancel it out. So the moment you substitute the y-intercept, so you substitute 0, m is cancelled out. So there's no m for you to find, basically. So in this situation, what we'll do is we'll use b. So b, we'll just sub b minus 2 minus 5 into y equals mx plus 2. Right? And then that gives us, for y, we substitute minus 5 equals m. And then for x, we substitute minus 2 plus 2. Okay. Then we just take this 2 to the other side. Okay, let me just fix my camera. Okay, hope you can see that. Okay. Then we have minus 5 minus 2 equals minus 2m. Then we have minus 7 equals minus 2m. And then we divide both sides by negative 2, and then that just gives us minus 7 over minus 2 equals minus 2 over minus 2m. That basically gives us m equals 7 over 2. Okay. Now that we've found the values of m and c, now we can just substitute m back into this equation here. So this is the last step now. So we just sub m equals 7 over 2 into y equals mx plus 2. And that gives us y equals 7 over 2x plus 2. And that is our equation of a straight line, of the straight line. Now, we're going to use the second formula to find the equation. So firstly, for us to use this formula, we have to find the value of m. Then to find the value of m, what we're going to do, number one, we're going to use the formula m equals y2 minus y1 over x2 minus x1, right? Now, before we even substitute the values, we need to know or map our values. So we're going to use b as x2, y2, and a will be our x1, y1, right? So let me just write it again here. So we have x1, y1, we'll get from a 0 and 2. So what this just means, as a side note, x1 is 0, y1 is 2, and then x2, y2 also, as a side note, minus 2, minus 5. Okay, once you have this mapping in your mind, so you have to be consistent in how you use these. So okay, what we're going to do is substitute the points a and b into the formula m equals y2 minus y1 over x2 minus x1. And then that gives us m equals, so for y2 we're going to substitute minus 5 as we mapped it out here. So minus 5. For y1 we're going to substitute 2, so minus 2. And then for x2 we're going to substitute minus 2. And then for x1 substitute 0. And that gives us minus 7 over minus 2, which just equals 7 over 2. So m is 7 over 2. Once we have the value of m, the gradient or slope of the line, the second step is to just using any one of these 2 points now. So unlike this example here where we couldn't use the y-intercept or the point A, in this case you can use either or. So you can either use the point A or the point B to find the equation of a straight line. So what I'll do is use A in this case. So I'll just sub A 0, 2 into y minus y So before I even go there, firstly I need to substitute, sorry, but I forgot to sub m equals 7/2 into this formula. So firstly we have y minus y1 equals 7/2 x minus x1. Now sub a into y minus y1 equals 7/2 times x minus x1. That gives us y minus, so for y we're going to substitute 2 for y1, and then we have 7/2 x minus, and then for x1 we're going to substitute 0. Now once we have that, we have y minus 2 equals 7/2x, and then 7/2 times 0 is 0, so that's cancelled out, and then we have y equals 7/2x plus 2. Again, our solutions match, and it also depends on your preference and the type of information that you are given in the beginning. And then now we're going to go to our last example. So before I even go there, just a reminder: if you're given the y-intercept and then you decide to use this method, remember that after finding the gradient, so you can use the y-intercept initially to find the value of c. You can use the y-intercept to find the value of c. But then when it comes to finding the gradient, you can't reuse that y-intercept. So you can't use the y-intercept to find the value of m, because that's just going to cancel the m out. So we use the y-intercept a to find the value of c, and then we use the second point b to find the value of m. So don't forget that. Okay, last example. So in our last example, we are given that a has the coordinates 2 and 4, and b is given by 6 and 12. Okay. And again, we're going to compare the two methods or the two formulas and see and try to get to the same solution. I hope that we get the same solution. So we have y equals m x plus c, and y minus y1 equals m times x minus x1. Okay. Now firstly, you'll notice here we don't have any y-intercept. The gradient is not given. It's just 2 points. 2 points on the line. Then we need to use those points to find the equation of a straight line. So what we're going to do here is find the value of m first. So you'll notice in this case it's usually preferable to use this formula here. but then as we said, we're going to compare both approaches. So firstly, what I'm going to do for this example, I'm going to start with this preferable approach or preferable formula, and then go back to this one. So starting off, the first step, we need to find the gradient. So in our previous example, we said m equals y2 minus y1, x2 minus x1. So I'll just call that equation 1. Okay. And then you remember we have to do our mapping here, so we know that b is x2, y2, and then a is x1, y1. So now we're just going to sub a, 2, and 4, and b, given by 6, 12, into equation 1. Okay. And then here what we get is m equals, for y2 we substitute 12, so y2 is 12. And then for y1, based on this mapping here, we substitute 4, so minus 4. And then second, we substitute for x2 we use 6, and then for x1 we use 2. And that gives us 8 over 4, which is equals to 2. So that's our gradient. Therefore, our gradient m equals 2. Now, the next step is to just substitute or sub m equals 2 into our formula. So y minus y1 equals 2 times x minus x1. Okay. Okay, and then sorry, this is m. This is m. Hope you can see that this is an m. Yeah. So we have y minus y1 equals 2 times x minus x1. Okay. Now, the next step is to use any one of these points. You can use any one of these 2 points, A and B, to in this next step. So in our case, because we already mapped A to x1 and y1, I'll just use that. So just going to sub A, which is 2 and 4, into y minus y1 equals 2 times x minus x1. And that just gives us y minus, so for y1 I'm going to substitute 4 equals 2x, and then for x1 I'm going to substitute 2 minus 2, and then we have y minus 4 equals 2x minus 4. Take this 4 to the other side, gives us y equals 2x minus 4 plus 4. Therefore, y equals 2x. And that's it. That's our equation. And then going back to this formula now. So I'm going to reuse the value of m. So we already found m, which is 2, using this formula here. We found that the value of m is 2. So I'm just going to start by sub m equals 2 into y equals mx plus c. That gives us y equals 2x plus c. And then step 3. Now in this case, because there's no y-intercept, you can use either one of these two values to find the 2 points to find c. So I'll show you both examples in this case. So I'll first use a and then I'll use b to see if we get to the same value of c. So firstly we're going to sub a into y equals 2x plus c, and then that just gives us, for y we sub 4 equals 2, and then for x we substitute 2 plus c, and that equals 4 equals 4 plus c. And then you can take this 4 to the other side, and then we have 4 minus 4 equals c. That just gives us c equals 0. Okay, now let's sub as the next example. Before we go on to the last step, I just want to show you that you can use either one of these two values. So now I'm going to find c again using b. So I'm going to sub b 6, 12 into y equals 2x plus c. Okay, and then for y we substitute, for y in this case we substitute 12 equals 2, and for x we substitute 6 plus c, and that gives us 12 equals 12 plus c. And then take this 12 to the other side, and that gives us c equals 0. Okay, it's the same whether we use a or b, we get to the same value of c. Okay, so now that we know the value of c, we can just sub the value of c. So this is the last step where we substitute the value of c into this equation here, and that should give us our equation of the straight line. So number 4, we just substitute c equals 0 into y equals 2x plus c. That gives us y equals 2x plus 0. Therefore, y equals 2x, and there we have it. Okay. Thank you guys for taking the time to watch my videos, and let me know if you do find the videos helpful by leaving a comment or liking the videos, and please don't forget to hit that subscribe button. Thank you. See you in the next video. Bye.